To be fairly honest, I did not do any internships in my undergrad.
Many individuals who develop an interest in science often find themselves drawn to astronomy or astrophysics at some point in their lives. Some even go beyond casual interest, earning to deep their understanding and make discoveries in these fields. One such individual is our first guest on the Metaverse Entangle podcast series, Saswata Dasgupta. Saswata is currently a graduate student at the University of Cambridge. He completed his BTech in Electronics and Communication Engineering from MKCV Institute of Engineering, West Bengal, and earned his master's degree in Astrophysics, Astronomy, and Space Engineering from IIT Indore. He also has a corporate experience which he chose to leave behind in pursuit of his passion for astronomy and astrophysics. Let's learn more from him. Welcome to the podcast series Metaverse Entangle. It's my privilege to have you here as my first guest.
Thank you for inviting me over on this channel. Thank
Looking
you.
forward to looking forward to know more from you. So we'll get started. Firstly, tell us about yourself, Bhaiya.
Well, to start with, I am pursuing a PhD in astronomy. Second year PhD. I'm studying from Institute of Astronomy, University of Cambridge. I did my master's from IIT Indore on astronomy, astrophysics, and space engineering. And before that, I was working for a couple of years, and I started as an electronics engineer to begin with. So yeah, that's a little about me.
Nice, Bhaiya. So our first question would be, like, what are you working on currently, and what your research interests are?
Um, all right. So I work on the domain of something called cosmology, which deals with the history and the evolution of the universe.
Right.
Now, particularly speaking, I work on this period of the universe, which is called the cosmic dawn and the epoch of reionization. Now, cosmic dawn is the period of the universe where the first stars and galaxies they started to form, and the high energy radiation that they emitted from these galaxies or first stars, they started to ionize the surrounding intergalactic medium, which consisted majorly of hydrogen. And this period of the universe is called the epoch of reionization. So my research mostly entails probing these two epochs of the universe, which is cosmic dawn and the epoch of reionization.
Right. So it's all about you trace your research back to the Big Bang and you primarily deal with all that.
Well, uh, to speak particularly about this, the event that I'm talking about, the time period that I'm talking about, that happens quite after the Big Bang. So apparently, as we know right now, we do have a fairly good understanding on how the universe was just after the Big Bang. So which is called so the first light that came out from Big Bang is called the cosmic microwave background radiation that we
Right.
can see. So we have a fairly good idea about the universe at the earliest stages, which is after Big Bang, when the first light was emitted, the epoch of recombination, or the cosmic microwave background, and we also have a fairly good understanding of what our present universe is. Um, Again, when I say fairly good, it's subjective again, but yeah, we do have a better understanding, at least, about the current universe and the earliest of the universes. But the if you think of it as a puzzle, the missing pieces are in between, where the dark ages, the cosmic dawn, the epoch of reionization, they come into play. So the beginning of the universe, as we look at the cosmic microwave background, we see that the universe was very homogeneous, and the matter density distribution, it was quite homogeneous. And when we look at our universe right now, we see that the fluctuation in matter density is quite high. You see, there are galaxies here, and then there is a big void, and then there are galaxies. So the variation in matter density is quite high right now, which wasn't when we look at the cosmic microwave background. So what really caused this phase transition of the universe from that period to the current
Right.
phase of the universe?
I
That
see.
is something that we've been trying to look at.
I
And to
see.
find missing puzzles, we look at these periods, which is called dark ages, cosmic dawn, epoch of reionization, etc.
So, since you mentioned that you are from an engineering background, like what made the transition from what made you take the transition from engineering to physics? Like, did you face any hardships, after making this transition? Why did you do it? Like, what instigated you or what inspired you?
Well, I was always passionate about this field of astronomy. It always intrigued me to study lot more about the universe. In general, I think everybody is sort of really interested in space science and all of that. But mine was I would say it was a bit particular on cosmology, and I wanted to do cosmology. But as someone who's studying, in a circle where people do not usually go to this path and they do not have any idea on this, it was actually difficult for me to get here. But honestly speaking, I really had the passion to pursue this. So I took a leap of faith, amidst the COVID pandemic, where I left my job, and I started preparing for these exams, competitive exams that I appeared for, just to get in a master's in astrophysics. So again, I would definitely say that that comes from a point of privilege that a lot of people do not have, especially in our country. But so to speak, I did have that privilege that I could take this leap of faith to pursue my passion. I was always interested, and also I would say that because I had this passion for astronomy, I tried to do projects during my BTechs which sort of aligned with physics. So if you look at my profile, I have done projects like digital interferometer, and my final year project was digital telescope, which you wouldn't usually find in a undergrad who's doing electronics and communication, especially from India.
Right. So next question, we'll go to the next question. Your MS thesis mainly focused on using machine learning applications in data analysis. How actually, what exactly was the actual application of machine learning? Like, how did it apply? How to what extent did it make the cut from other old conventional fields? I mean, conventional methods.
Right. I mean, to be fair, I think we do not have a very long time to speak about this, because I would love to speak a lot on this, but I'll try to be as concise as possible to talk about this.
So this
So
was one of my personal favorite questions. So
no, absolutely. I mean, the world is going towards this AI and machine learning revolution, as a lot of people say. So I would say the way I was using machine learning in a way was something like this. I'm not trying to make this very on a very vanilla level, because I do not want to go to the niche and the details of the things that I did at that time. So the my problem the problem that I was dealing with at that time was to discern between ionized regions in the universe, or a map. So in that map, I had to sort of discern between ionized regions and neutral regions. Now, so to speak, that that problem becomes a lot difficult when your image has a lot of noise, and we have something called galactic and extragalactic foregrounds. So
Mhm.
now to make these, to distinguish these features in a map, we try a lot of conventional algorithms, and they do seem to have a lot of bias and a lot of problems. So apart from doing, I mean, alongside doing these problems, we also tested different machine learning algorithms to discern between these ionized and neutral regions. So fairly speaking, again, if you treat your machine learning algorithm as like a black box, I don't think that's the best thing to do. You need to understand your problem a little better when you apply. Back in the day, I think I was quite naive, that I thought that machine learning was sort of a cheat code to some problem, that you have this question where you can't find an arithmetic solution to something, and so you just put it, you train your you train your model with that, and then you sort of get to a final answer. But that's another thing. We try different methods. Machine learning is one of them. I would say it was aiding to what we were trying to solve, but it was not the only thing. So yeah. So my advice to people who are in the field of machine learning, who are just starting in the field of machine learning, do rely on conventional methods, because they are pretty good at times. They are sometimes better than machine learning. So only apply machine learning when you think it's necessary, because yeah, it may not be necessary to your problem at all sometimes.
like, may I know in what way the conventional methods are actually better than machine learning? Can you give me like one, two instances or like that?
Oh well, so now let's think of this problem that I was dealing with. So I had to discern between ionized and neutral pixels in an image where I had a lot of noise, right? Now, My way of doing it was to look at the histogram and recover that histogram using some sort of an ANN. Or what you could have done was, use some kind of a CNN based method
Mm.
um, to, recover this pixels. But there are algorithms like something called a triangle method, which I found out later on, which was pretty useful, and you did not require any fancy algorithms to do that. Your SciPy already had that built in, and you could, do this at least for certain maps, for certain kind of images. You could have done it. So we didn't really need machine learning for that, because machine learning requires a lot of data to train on, and then
Mm.
you take a lot of time to train, because you need to have a big set of
Right.
data just to train your model.
I
So
see.
that was probably not required. So in that particular scenario, I think k-means, or the triangle method, it did a better job.
Nice. And like you also have a lot of experiences in imaging black holes. Can you describe the processes? Like know
I
what
think okay. I think we are misunderstanding this thing. So I did not work on black holes, but I did imaging
Hmm.
on cosmological maps, which are not technically black holes. So you may find a black hole in one of those maps, but it may be less than a pixel. So what we dealt with was very large scale universe maps, which are in 500 megaparsecs, or 300 megaparsecs, like big boxes that we were trying to deal with. And in those boxes, one pixel may be a galaxy cluster. In and
Hmm.
in a sub pixel, you will have a black hole. So I was not really working on imaging black holes, but I was definitely working on imaging. What I was working on was to see how these images would look like with a future telescope, which is currently, getting built in different parts of the world. It's called the SKA, the Square Kilometer Array, which is supposed to be the largest telescope when it's built in the world, when it's built. So I was trying to, simulate how the maps would look, how these images would look if they were being looked at by the SKA.
Right. So we'll get a bit non-technical in this question. What made you choose Cambridge over other institutes, or like what? Why not India or the US? Yeah.
Right. So to be fairly honest with you, I did not choose Cambridge.
And what
I
made
was
you think that what made you like? What do you think that made
yeah,
you get in Cambridge?
absolutely, absolutely. So I when I was looking for PhD positions, I majorly focused on Europe and the UK, because of two reasons. A, the tenure was 3.5
Hmm.
years, which is fairly shorter than as you would expect in India or in the US. And secondly, I think what I've heard is that the culture is really good. The work
Hmm.
culture in Europe in general, it's really good. That's what I've heard. And I knew a lot of people who were doing PhDs, or they did their postdocs. Even my then supervisor, and he did his postdoc, both of his postdocs in Europe and the UK respectively. So I had a bit of knowledge about that. And one more thing that I should tell you is that I only applied to the places where the application fee was zero. So that was something I also was looking at, because I left my job at that time, and I was living on stipend. So finance was a very important thing for me to look at. So I was only applying to the places where there was no application fee. And fortunately, from that very year, Cambridge, I don't know about the other departments, but my department, the Institute of Astronomy, they stopped taking application fees. So their application fee was zero. So that sort of made me choose it. And again, I was only applying to the institutes where I could see the kind of work I was doing in masters were being aligned to. So
Right.
I I
So
wanted to
the
stay in
so the main reason
especially.
would be your master's thesis.
Right. So so
In
so the way I was groomed during my masters, so I already wanted to do cosmology. I was doing cosmology, but I was doing a particular kind of cosmology. So you have different kinds of cosmology as well. So I wanted to stay in this dark ages, cosmic dawn, epoch of reionization physics. I didn't want to, go to CMB or some other kind of cosmology.
Right. And how many internships did you take when you were in your undergrad, and like when would you like suggest one can start his internships?
Well, to be fairly honest, I did not do any internships in my undergrad, but we had this mandatory training that we had to do as a part of our coursework back in my undergrad when I was in, in West Bengal. So I did one of those trainings from WB REDA, which is West Bengal Renewable Energy Development Authority. And yeah, at that time, so I gained some idea on how solar energy works and how it's how they distribute this sort of these sort of things in India, especially in rural India. So I had some idea on that because I was doing electronics anyway,
Mm,
so that was a part of my mandatory training. But there's a fun story that I actually wanted to do an internship in Fourier imaging or Fourier optics
mm,
from IIT Kharagpur, and I wrote cold emails to some professors, and they never responded. So that's I tried doing it. Even when I was in Indore, I tried during my masters. I tried applying for an internship to Astron, which is in Netherlands. But then again, I didn't get through. So I was not selected for the program. So yeah, I couldn't do any internships, to be fair.
right. So, how is India developing in astronomy and astrophysics? Like considering institutes like IUCA and IAST, is there any specific domain? Like, what do you think Indian institutes are better than their global counterparts?
Okay, to be fairly honest, I think I'm quite young to answer this. Maybe not the right person as well, because I do not have a very clear idea on how the Indian astronomy overall situation works. But so to speak, the time when I was applying for masters and I was trying to look at different universities, one of my key choices was IST Trivandrum.
Mm,
Again, I also looked at Ayuka because they at that time they had this separate exam that they conducted for Ayuka. The particularly for cosmology, for the kind of cosmology that I do, there is IIT Indore. IIT Indore is really good. I think my department is really good. The faculties that we have at IIT Indore for other streams as well, like some people do astrophysical fluids, some people work on black holes. So I'm sure they do really good research in IIT Indore as well. Um, I know that even in Kolkata, I have been to this place called ISI, I think Indian Statistical Institute.
mm,
You know this is
yeah,
so even a lot of people don't know this, but they do work on cosmology in ISI as well, because cosmology is very statistical. You need to have statistical knowledge to do cosmology.
right.
So that happens. IIT Kanpur also now has an astronomy department. In IIT Madras, there are groups where people now work in cosmology. IIT Kharagpur has a group in cosmology. So there are a couple of places where the NCRA is again one of the premier institutes where they do these kind of research based research on astrophysics and astronomy. So it's pretty good. I would say there are very good people. I in Cambridge, I am a part of this collaboration called Reach, and there
Mm,
are a lot of Indian people who are actually working in Indian institutes who are part of this Reach collaboration, which is a global collaboration again. So again, so to speak, there is no such competition where one would do better or worse. I would say we work hand in hand, we collaborate because it's science, right?
amazing.
So yeah,
Nice.
so that's I think how it works. But yeah, again, not the best person to answer this question.
And talking about space science in India, like your views on our space docking achievement, ISRO's
Sorry.
recent, our
Yeah.
your views on that. Like, what do you think?
I mean, of course, it's an amazing feat, especially given the fact that we have so much of budget constraints.
Hmm.
When you think so people sometimes they ask me this question that what if you were to choose between NASA and ISRO, what would you choose? Again, this is I think it's a question that comes from naivety, that people don't really understand this, that they're not competing each other, so to say. They again work hand in hand, um, because as you know that ISRO aided a lot of satellites to launch with
Hmm.
their PSLV. I may be wrong. Sorry for that. But India was aiding with ISRO. They were aiding a lot of other countries to help them launch their satellites. We do that, um, and especially the fact that we could do it in such tight budget constraints is a massive. It's a massive feat. I think no other country can do such kind of science with such tight budget constraints. So it's an amazing thing that people can do.
Really. Yeah, like when I got to know this, like I was really happy, and I wanted to like check more on how did we ever do this like despite our heavy budget constraints. Credits to our
Absolutely. Yeah.
scientists on that. The next important concern of Indian students like wanting to pursue a PhD abroad is the main concern is the funding. And you being a fellow of Cambridge International and Isaac Newton studentship, like what do you think and like what made you think that like how did you get your studentship and how do you manage your expenses? And how is the
Okay.
funding scenario actually?
Yeah, it's in the UK particularly, it's very, very, very tight, to be fair, especially for international students because you face competition from all over the world, right?
Hmm.
And unlike the US, the project doesn't like come associated with the funding itself. So you don't have an attached funding with your project, so to say. So again, it's quite difficult. I really, really would want to know the process in detail if someday I am in one of those committees where I look at people's applications and get the guidelines to what they see when they select candidates. But I think what I what I did well, especially with the help of my current supervisor, because she was also very supportive, and my previous supervisor as well, is that I had to write a research proposal, and that research proposal, I think it was concise. And my previous supervisor, Dr. Shuman Mujumdar, he also mentioned that there may be people in your evaluation committee who may not be from science at all. So you may need to write your proposal in a way that it's very general to people. Also, it doesn't lose the scientific details of what you're going to work on. So maybe there are, like, let's say there are 500 applications that they have to go through. So if your title is a bit catchy, but again it doesn't lose the science, your introduction section, it's quite general for people, but then again it actually tells about what you're going to work on. I think that helps. And I got amazing professors. I still have amazing people that I work with who helped me a lot in my work. So I think the credit just doesn't go to me. It's shared among everyone, especially my friends at that time also. Here also I have friends in the UK. I have a friend from IIT Indore. She was a senior. She's here working in Jodrell Bank, Manchester, in University of Manchester. So she also helped me because she had an idea because she was senior, so she had some idea on how she was writing her applications and all of that. So that helped a lot.
Good to know. And you were also in a corporate firm before starting your grad school. What factors made you leave your corporate job? If you don't mind telling us about your experience during your corporate life.
Well, to be fair, I was working in Coimbatore for
Oh,
an automotive company. Yeah, and
I guess you
it
would
was
have, you would have like a higher pay over there.
yeah,
I may be
absolutely.
wrong. Correct me if I'm
No,
wrong.
no, no, you're right. You're right. I mean, absolutely. Uh,
And
Again,
me being
from
from Tamil Nadu, like I know what Coimbatore is.
yeah, and especially someone coming from a middle class background, leaving a job at that time, it's quite difficult for the family as well because I had conflicts with my family because of this. And to be fair, the company that I was working with, they were really good. They had really good work culture. I had good work life balance and all of that. So my company was very, very good. But you know, I wanted to do something else. So my passion was the only thing to leave my company and not anything else, to be fair. And that sort of made me leave my company, drop my papers during the pandemic, which is a the kind of the bad it's one of the bad times to drop your paper. So but then yeah, I took that risk because yeah, I think something was telling me that this is the best time to do it, and I'm glad that I took that decision, and it helped me.
Okay, next we have a couple of personal questions from the student side. So the first question will be like, how does being in science clubs help shaping one's career? And tell us about your experiences. And yeah, I also know that you were part of IIT in those astronomy club. And tell us about like your experience in the clubs and how did it shape you and in what way did it help you?
I mean, you get to learn a lot of things, managerial skills. you know I think interacting with people, is networking is a very
Mm.
important skill to have, especially if you're in research. um so so one of those things, again, you learn a lot of things which, even though you're in the field, you may not know, right? and you get to meet a lot of people who you can, collaborate with in the future. So I think being in a culture where people share similar thoughts, you can, it's diverse, people from all different backgrounds, they come. So let's say some computer science engineer, he's also a part of this club, and let's say some electrical engineer he's also a part of this club, and then some physicist who's also a part of this club. So the exchange of ideas that can happen, it's diverse and it's really good. Maybe the guy from computer science, he may give, talk about some algorithm that you can apply to your own problem, which is very helpful. So I think
Right.
these kind of, collaborations, these kind of meetings, they really help to shape your career. If you're with the right company, I think, that'll aid you.
Right. So now, what are your future plans? Like, what do you want to do? You wish to stay in academia, or like you want to, switch? Like, what? Most probably, I don't think you will ever make a switch. So, what are your future plans?
Well, to be fair, I'm current in my second year. So how I look on this thing is in this way, that I would first like to, uh, you know, be a good researcher at this point. You know, establish myself as a good researcher, as a good PhD student, and present my work around the world, where I get to do for a conference, or for a seminar. Learn a lot of things, learn skills, maybe learn different algorithms, statistical tools. So that helps in a lot of way. um, this, I think, one of these things that I always have in me is that I really want to give back to my country.
Amazing.
So yeah, so what I think is that, so back when I was during my masters, when I was working, even when I was working, I was teaching underprivileged students for free. I want to continue doing that, but in a more, structural way. So that's
Amazing.
that's something I
Nice.
really want to do in the future. Again, career wise, yeah, of course, research is something that actually made me take certain steps that I would have, never did. So yeah, research is probably something that I'm going to pursue, but alongside, I'd also want to, help people, especially from underprivileged backgrounds. And underprivileged is a broad term, so they can be underprivileged in a lot of ways.
You
So
really
again,
have a very good vision. Like, we wish you the best of luck that it happens.
thank you so much, thank you so much. Yeah.
And if there is there anything like you could, if you could time travel and go back and fix something, what would it be and why?
When I look back, I think I wouldn't change anything. So I think this is going to be a little philosophical. So I think there's something in causality. So I think the chain of events that has happened in the past, I think that has led me to where I am right now, and maybe what I'm doing. So maybe let's not change anything. Everything that has happened is happened for a reason.
So you're happy with whatever you are now, and like you trust the flow.
Yeah, absolutely. So the only key difference that I think is that when I was working, and when I'm working here right now, so when I was in corporate and when I'm here right now, so in every field in the world, everywhere you go, you will face, downfalls, you have setbacks. But what is the setback that still you want to endure, and then you want to come out of it, is something that is associated with your passion. So I think even the setbacks here, when I have here, I get frustrated, but I remind myself, I always wanted to do this. So it's fine. I have setbacks, and I can, jump back to, something good. So yeah, that helps.
And the most repeated question like is that like how do you handle failures?
Oh, well, keep working. I think the best thing is that keep working, or again, it depends. It varies people to people, and time to time as well. Because sometimes when I'm like, something's not working for a long time, I keep pushing myself doing it, and my friends tell me that, stop doing it. And when I listen to it, it actually works. I stop working for a while. I take a holiday. I go somewhere. Have fun with my friends. I come back. I start with a fresh mind. It helps. Sometimes, I stick to it. I make sure it's done. So sometimes that helps as well. So again, it depends on the context and the time where I'm facing this kind of a problem.
Nice, man. So we are getting closer to the end. So the final question would be, what advice, your final advice for younger students, preferably students who are in their undergrad or high school, or students who are doing their masters? What would one be your like final one liner or preferably advice? Like,
I think especially for undergrads, I would say that, do a good project, which is, I think, it's really underappreciated. If you can do a good project, then I think that helps a lot, because during my interviews at IIT Indore, I was being asked questions from the project I did during my BTech.
okay,
So that's very important. And also, like, project gives you a lot of hands-on experience that you may not learn through theory.
right.
So again, I did not, I was not an expert in cosmology when I started doing it, right? Because I transitioned from electronics to this field. So I think it's very important that you do your project sincerely, because as we already know that, especially in private engineering colleges, there is this thing that even you ask someone, and then they can do your project literally. So do not fall for that. Do your project sincerely, learn, enjoy learning, and that'll take you to good places. So yeah.
So, and I think we are done with all the questions. Thank you so much, Bhaiya, like for doing this. It was really an amazing experience interacting with you. Got to learn a lot, and thank you so much, Bhaiya. Pleasure having
Thank
you
you so
here.
much for inviting me. Thank you so much. I had a good time.
If you found the podcast interesting and informative, please subscribe so you won't miss any updates. I'll make sure to post a video at least once a month. If you have any suggestions or tips for improvement, kindly let us know by emailing to metaversentangle@gmail.com. Thank you, and I hope to see you in the next video.